All right, so resuming our notes. We're on example 9 of 3A.2 part 1. So we have 5 to the negative 4 times 5 to the third. When we left off in class, we talked about if the bases are the same, then there are certain rules that you follow for their exponents, correct? So our bases are the same. So what's the rule we're going to follow for our exponent here? You just had good practice. We're going to follow the product rule. The product rule is saying that I'm only going to make one base, and whatever my powers are, I'm going to add them together. So we end up with negative 4 plus 3. If you owe me $4 and you give me $3, you still owe me $1, right? What does it mean when you have a negative power? It goes where? To the denominator. So my final answer should be 1/5. Notice that a negative power does not make my number a negative. It means it belongs in the denominator. Okay? Questions so far about number 9? All right, number 10. What rule am I following here? Power of the power rule, right? Power of the power, I'm going to call it power squared, right? Power of the power means that when you're going to distribute, mathematically distribute means we are multiplying, right? When I am distributing, I am multiplying. So we're going to distribute that 2 to the negative 3, which puts this as 2 to the negative 6, which means that this all belongs in the denominator. Does that make sense? In the denominator, you're going to evaluate what is 2 times 2 times 2 times 2 times 2 times 2. Well, that's easy enough. 2 to the third is going to give me 8. And then another 2 to the third is going to give me 8. And 8 times 8 is 64. So this becomes 1 over 64. Okay. So after seeing these skills together and the practice, what I'd like for you to do is I'm going to give you approximately 60 seconds to do number 11. Thank you. All right. Let's see what we did. Okay. So the first thing you had, what rule did you follow first? What's the first rule? Product. You should follow the product rule first. Okay. So following the product rule, in the numerator, you have negative 3 plus negative 5, which makes it 8 to the negative 8 over 8 to the negative 9. Okay. At this point, you could choose to use the negative rule now, or you can wait to use the negative rule. Does it matter when you use it? No. I'm going to choose to use the negative rule now. So I'm going to apply the negative rule. The negative rule says that if I have a negative power in the numerator, it actually belongs in the denominator. If I have a negative power in the denominator, it actually belongs in the numerator. So I'm going to go ahead and make that change. And that gives me 8 to the 9 over 8 to the 8. My last rule I'm going to use is the quotient or division rule. These notes call it the division rule. I grew up calling it the quotient rule, so it's kind of hard for me to stop saying quotient, but it's the quotient or division rule, which means that you're going to do what with the powers? Subtract. So we have 9 minus 8. So we have 8 to the 9 minus 8, which just simply equals 8. So your final answer should have just been 8. Remember, if you're in a position where you can't see or you are blocked, you can always open your Canvas, click on the Zoom link, and you can view it right in your face. All right, you should have a blank page on the right side of your notes. You're going to split that blank page in half. Either way, whichever way your heart tells you, you just need two sides, either up and down or horizontally. Whichever way makes your heart happy. Mm-hmm. No. I got rid of it early. Then you would have had -8 minus -9, which is still +1. So it's just been 8 to the 1. If you didn't, this would have been 8 to the -8 minus -9. And a negative of the negative is a positive, which still makes this 8 to the 1, which still would have led you to. Why would I divide 8 by 8? You're using the exponents. I'm not dividing. Because of the power. Think about your PIMDAS, order of operations, right? Order of operations says you deal with your exponent first. So before I even can get to division, I have to deal with my exponent first. Exponent rules trump. All right. So we're going to do two types of problems. These are going to be the hardest types of problems that we would do. We're going to do the first one together and then the second one. If you can do the second one by yourself, then you're golden. All right. So you're going to write down this guy. Oh. On one side. This is the one we're going to do together. Hey, hey, hey. Two more. All right. Did we all get it written down? All right. So you should have written down 5 times x to the -4 times y to the 3rd divided by 8 times x to the 5th, all multiplied by 3 to the x to the -3 times y to the 5th divided by 6 times y to the -4. Okay? When you have something this large, you want to follow the rules of working left to right, top to bottom. Does that make sense? We're going to work left to right this way. That's how left to right goes. We're going to work left to right, then top to bottom. Capiche? All right. So the first thing that I want to remind you guys is that I know it's going to sound like kiddie-ish, but these are big numbers. Big numbers have big rules. They have different rules. Those rules you learned in elementary. Do not change those rules. Okay? When you are dividing numbers, you're just dividing them normal. Okay? When you are simplifying, you are just simplifying. A negative number does not become a positive number because the power is negative. None of that comes into play. Okay? Big numbers have big rules that you've been using since elementary school. Do not change those rules. Okay? Exponents are little numbers. They have the rules that we're following. Got it? All right. Here we go. So starting off, I'm going to go left to right. So I'm starting with this, my first factor here. My first factor is going to be 5x to the negative 4 times y to the third divided by 8 over x to the fifth. Only thing that I can do here is deal with the x's, right? That's the only thing that's changing there is dealing with the x's. I'm dealing with the x's using the division rule. What does the division rule tell me to do? Subtract the exponent. So I'm subtracting negative 4 minus 5. Does that make sense? Okay. 5 over 8 is just a fraction. It's going to say 5 over 8. It has nothing happening to it. But negative 4 minus 5 makes negative 9. Does that make sense? And y to the 3 had no friend. Okay. Now we're going to switch over to the next factor. The next factor, we start off with 3 over 6. Can I do anything with 3 over 6? Yeah, I can. What can I do with 3 over 6? I can reduce it, right? It reduces to 1/2. So 3 over 6 reduces to 1/2. Are you with me? Anyone sees that? We all see that? All right, x. Does x have a friend? Nope. So I'm just going to say x to the negative 3. But I do have a y and a y. Division rule again. The division rule says I have 5 minus negative 4. So I'm going to write it so you can see what I mean. We have y, okay? Y to the 5 minus negative 4. What happens there? It becomes positive. A negative times a negative makes a positive. So it becomes 5 plus 4. And what is 5 plus 4? 9. So this becomes y to the 9. Do we see how we applied the division rule? 3 over 6 reduces to 1/2. Sometimes you got to see it separate. Okay? Questions about the division rule being applied? Are we okay? All right, now, after division rule, what rule can I apply? Product rule. We're going to multiply and use product rule. Okay? Product for big numbers is still just regular product, right? Product for big numbers just means I'm multiplying the big numbers. So the things that are being multiplied, I have 5/8 and 1/2. They're going to be multiplied together. I have x to the negative 9 and x to the negative 3. They are going to be multiplied together. I have y to the third and y to the ninth. They're going to be multiplied together. Does that make sense? When you're multiplying, you're going to multiply where you can. Product rule. There's the product rule for big numbers, and there's the product rule for little numbers. Product rule for big numbers, we are just doing 5/8 times 1/2, which means you multiply your numerator to numerator, denominator to denominator, correct? So what is 5 times 1? 5. What is 8 times 2? 16. I'm done with that one. Product rule for exponents is different. Product rule for exponents tells me I'm doing what with negative 9 and negative 3? I'm going to add them. So I have x to the negative 9 plus x to the negative 3. What does that give me? X to the negative 12. Okay. Product rule again. Y to the 3, y to the 9. So we have 3 plus 9. What does that give me? A positive 12. What is the last rule that I'm going to apply here? Definition of a negative number. I have to use the negative rule, which leads me to 5 being in the numerator and y 12 being in the numerator. But in the denominator, I'm going to have 16 in x to the 12. And that is my answer. Do everything in parts. And so many of you are so used to not showing work because of Desmos, which is what I'm coming to the conclusion of, that a lot of your Algebra 1 was spent in Desmos. And therefore, you struggle with actually having to show work so that you can track what you're doing. You have to break that habit, okay? Yes. It is in the top. I was like, did I not? It's in the top. It actually can be in the front. It's not going to make a difference. A number in a numerator is the same thing as it being a whole number in front. Remember, well, when you first learn about fractions, eventually you should have learned that if it's in the numerator, it's being multiplied. If it's in the denominator, it's being divided. So whether the 5 is in the front or in the top, it's still something that's being multiplied by, right? Okay. All right. How do you feel? Doable? All right. This is your Big Bertha. If you can do this without any assistance, just follow the rules in your big, beautiful brains, then you got this. And the maze will be easy. Okay? All right. Write her down and give it a shot. Oh, there's supposed to be a 2 here. Do y'all see it now? Pretend it was there the whole time. Again, remember, we're going to solve it left to right, top to bottom, and then repeat. Left to right, top to bottom. All right, I'm going to put 2 minutes up. Okay, so let me close out our time. All right, so again, working from left to right, we're starting with our first factor here, right? That's fraction. So I'm going to highlight the things that are the same just so you can see what I'm doing. We have, x to the negative 2 and x to the negative 3. We then also had y to the 3 and y to the 2. So those are the things that I'm going to start off with. And I'm starting off with the what rule? Division rule. So x to the negative 2, negative 2 minus negative 3. Okay. So again, sometimes you got to see it. Negative 2 minus negative 3 is going to equal 1. So that's going to leave me with x to the 1. I'm going to write it a little smaller because I need more space. X to the 1. So now we're going to have y to the 3 divided by y to the 2, which means I have 3 minus 2, which is just going to be y to the 1. And z to the negative 1 had no friends. Still with me? All right, moving on to the next side. We have to use power of quotient, right? Power of quotient tells me that if there's a power on the outside, it has to be distributed to every factor in the numerator, every factor in the denominator. So when I distribute, that's going to leave me with x to the 2, which is times negative 2, which makes this x to the negative 4. Then we have negative 2 times negative 1, which makes y to the positive 2. Using the power of 1, there's a 1 there. So 1 times negative 2 is going to be z to the negative 2. Power of quotient. So we're distributing the power to every power on the inside. And distribution mathematically means we are multiplying. So we have 2 times -2, which gave us -4. All right, numerator is done. Now I'm going to do the denominator, 2 to the -2, and z to the -6. This is not simplified, so I'm going to keep going. So looking at this one, I'm asking myself, what are my like variables? And on this one, I have only the z, right? So let's make z 3. So I have z to the -2 and z to the -6. Mhm. The distribution. So in this case, it's going to still come out to be the same. Yeah. So you did the z's first. Did you do your z first? Yeah. It's going to come out to be the same. -2 minus -6 is still going to give me what? 4. Yeah. You're welcome. That's what I'm here for. All right. So back to what we were doing. So this again, this is subtraction. So in your brain, you should be -2 minus -6. A negative and a negative makes a positive. So it becomes -2 plus 6, which is 4. Okay. If you have a negative bank account with $2 in it, you go deposit $6. You now have a positive bank account with $4 in it. Okay. So your Z is going to be 4. Next thing I'm going to simplify, I'm going to do my 2 to the -2. 2 to the -2 does not mean -4. 2 to the -2 means that this is 1 over 2 squared, which equals 4. Does that make sense? One over 4. But it's in the denominator. So it's going to end up moving to the top. All right, so here we go. So I'm down to x, y, z, -1 times x to the -4, y to the 2, z to the 4, and I'm going to write it so you can still see it as 1 over 1/4. Which is why it's going to end up in the numerator anyway. All right, now you're left to right again. So left to right, I have x and x to the -4. What do they make? You're adding them. Product rule. So there is a 1 here. And what is 1 plus -4? -3. So that's x to the -3. Now we're on our y's. So we have y1 and y2. What does y1 and y2 make? y3. Now we're on to our z's. We have z to the -1 and z to the 4. What does that make? Z3. And then I have 1 divided by 1/4, which is just, what's 1 divided by 1/4? 4. You keep change, flip, you reciprocate. Is that my final answer? No. What rule is the last rule I have to apply? The negative exponent. I have that negative. So everybody's in the numerator except, so we have 4y to the 3, z to the 3, and then x to the 3 is in the denominator. Because it is what? Negative. If you made mistakes but see your mistakes and have corrected them, then the maze will be easy. All right. Part 1 is done.